Hello to anyone watching. It's time to continue where I left off, and I have found out what I did wrong. And why I didn't get the right answer before in part 8. So, last we ended off, it works on the test input, didn't work on the real input. I ended up finding the problem. Specific piece of wording in the actual challenge instructions. Turns out I misinterpreted something. Which is... where is it exactly? Yes, this right here. So, what this means, if these are next to it the shortest distance, they're already in the same circuit, it says nothing happens. What I thought this meant was that you don't make a connection at all because, well, nothing happens, so why would anything have changed? What you're supposed to read is you make the connection, incrementing connections made, which is what I've done here now. And with that, I should probably show it, I've added that line right here, single line added. So nothing changes in effect because... in fact, nothing changes, but it is counted as an edge you've connected. So with this, it should now be correct. I've not tested it yet, but I do know that it still gives the correct output for test input. Now I want to see if it's right. Here, it still gives the correct output for the test input. Question is, does it give the correct output for the real input? Well, if you do get more than 10, of course. 49,500. And those are already much smaller because now it has made fewer connections, meaning these circuits are smaller because they haven't joined as much. Question is this correct? If not, then that is a big problem. Uh-oh. Now it's too low. Different from before because last time it was too high, so... Question is, why is it wrong now? Hold on, I did. Yeah, why is that still wrong? Now this is going to be annoying to debug. If I can't figure out easily, then I might look for some more hints online. I hope I don't need to, but... And what I could do... So the way I see it, every edge that I pass... Now, every edge that I use is... I don't think I even need edges anymore. Or at least not like this. Connections made is one, I think. Here are connections made. Wait a second. Can run here. Well, that can run for every circuit, so that's not good. Oh, I might have made an oversight here. doesn't create a connection if it's not in there. That part is bright, I think. There shouldn't be a way in which... Uh-oh. I see an issue. No, wait. If I find that one in this one of the circuits, then it'll terminate. It's because this is guaranteed to catch those cases where... This should already catch all the cases where it joins two circuits. So this means that it's done. Shouldn't need this, but I'm going to add it in just in case. It's all else is. It shouldn't change anything, right? It doesn't, so... The end here, how many? Should simply be, yeah, exactly 1,000. So then why is it wrong? I think I want to test something. Not every vertex should only ever be in a single circuit, so... That's not that in Nexus 2. Crashes, that should tell me at least, or at least give an idea of what's wrong. Unfortunately it doesn't, which means that this does hold true. Each vertex is only in a single circuit. Okay. Exact. Yep, each vertex occurs exactly once. But why is it wrong? I've already found the distance function is correct, but can't imagine basing this wrong. Then what is wrong? Okay, what is wrong then? I'm afraid I'm gonna have to look for some hints because I do not know what's wrong. Yeah, I'm just gonna have to keep looking. Well, at least it looks like I'm not the only person who's struggling with code only working on test data. Unfortunately, all the problems people are having so far aren't the same problems I'm having. Okay, what am I missing? Just gonna keep looking what's wrong. Maybe. Hopefully I can find something. I'm gonna have to poke around a bit more, I think. What if a ditch connection is made? Because we'll always make a connection. What I can do is just... Okay, what's now? Don't need next edge anymore. Since it always makes a connection for every edge. Am I reading this correctly? That each edge always gets added. So should be min connections and edges of LAN. That gave a different number. Does it still work on test data? It does not. Probably because it was set to 1,000 though. I'm not sure why this would work, but I have a feeling it might. On account that it does give a different answer for some reason. It is between the two previous ones. Oh, did I forget to? Okay, so I rewrote this. Instead of keeping track of connections made, which I can delete altogether, I'm just gonna loop 1,000 times. Also make sure not to go over edges, but... Question is, where is the index overflow then? Whatever, oh, it's right, it's the printing at the top. Question is, does this now work? I hope it's not the answer. Oh. That was... All I have to do is actually loop 1,000 times. That's a shame. Well, at least that part's done. That one can go. Code is committed. Alright, part 2. Oh god. Ugh. Oh, that is... I'm gonna have to rewrite my code a bit, I think. Don't know how I'm gonna do that. But... let's see. think. Oh, for this one I want a lifetime. Because this thing is going to be tied to you. Because I'm going to be returning vertices from that list. This algorithm is going to be quite similar at least. Actually, I think I want to do this slightly differently where I can just keep reducing them. I think the easiest is... I can do for each. Just you know that is not like this. That's more like it. If I just start with each... If I just start every iteration with... Like, if I start here with each vertex as its own circuit, then all I'll ever need to do is merge them. Which simplifies the code a bit. Now I can just say, while circles of len greater than 1... Can I? Oh. Oh, yes! While blocks are expressions, are they not? I can return the last pair at the end. Oh, that is beautiful. Just iterate the edges. That's not what I need. So that can get me edge I need. Then I can just say, because these are already sorted, I can just can just modify circuits here. So to find C where C contains starts. That will always be in a circuit. Let's see. And so if the two circuits are the same, that means we don't need to combine. So now I can say I think position is better. Position is nicer because I can use sizes. So I can just say do that. Well, I need to clone these. With capacity, their lengths, extend S. That doesn't work. Oh well. Now I can just the lifetimes do check out because I'm borrowing from this array. Yeah, because it's borrowed because I can. Clone, why are you? That works. Do I now need clones still? Can I share off? No, I cannot. I can just say remove. Since these are U sizes, I can that might not work actually because the indices will shift. Oh, that is an issue, actually. So I have to remove multiple without Lindsay's. Right, if I work reverse, it's fine. So then, now I can do. Importantly, for the other case, I need to move them in reverse order to make sure the indices don't shift around too much. And finally, it shouldn't be there. Push new. And now just keep merging every single time. Also, this should be in here because only is on merges. I think this works. Let's hope I'm correct. Because if not, this is just going to be annoying. Just in case, I'm going to run with test input first. Okay, let's see. Take a quick look at the challenge actually. Okay. No. Also, I can now silence all of these. Just don't need all these printlins anymore. I found the bug already. Okay. Now that needs to be. Almost. Does that work? Not quite. Is that correct? Hold on. I just looked at the output and that is... Yeah, that's a bit stupid, isn't it? Yes, joining the same vertices together. How does that happen? because they're both set to 0, which is 0th index, which means so then well, that will do it, won't it? Okay, now it doesn't work. That's how is that possible? I really need to pay better attention to what I'm doing. Otherwise this is just gonna keep happening forever. Ooh, that's better, I think. Those are correct. Let's find the correct indices, let's go. Here I can do does in fact give the correct no. Yep, that's correct on the test input. So obviously that means that this input is going to be wrong. Did find both of those. Let's see. Oh, let's go. That's the challenge done then. Awesome. That moment when part 2 is easier than part 1. Honestly, that is not what I expected. But I'll take it, I guess. Yeah. That's me done for today. And with that, I am finally all caught up again. Nice. Well then, since that's everything, I'll be back for tomorrow, I guess. Hopefully I'll be able to solve... Yeah, hopefully I'll be able to solve tomorrow's challenge without too much issue, unlike today. Anyways, until then, see you later.